I think we're hearing the countdown right now from the Kennedy Space Center down in Florida, Ed. And for those on the radio, we're seeing the ignition now and the liftoff. It never gets old, does it, Ed?
Yeah, it never gets old. And look, what happens over the next 90 seconds or so is that the Falcon 9 booster, that's the long part of the rocket we're seeing on our screens. For our global radio audience, the Falcon 9 generates a hell of a load of thrust. And on its way up, it accelerates to 17,000 miles per hour to get them to that orbital path on its way to the International Space Station. You know, what happens over the first sort of 60 seconds or so is that the complete spacecraft, which is made up of the booster, the second stage, and the capsule on top of it, reaches a moment of what we call max Q. That will happen in about 10 seconds' time, David. That's the moment of maximum aerodynamic pressure or stress. And in that time, you know, these astronauts, these crew members, they're going to feel 4.5 times G-forces. Can you just imagine that stress as you pass through Earth's atmosphere?
No, I can't imagine it. At the same time, how long does it take to get up there? There are, I guess it's 3 astronauts and 1 cosmonaut. How long until they get to the International Space Station?
Yeah, so to kind of get to the official boundary of space, it's around 2 to 3 minutes. And then once you have breached Earth's atmosphere and you have the first stage booster separate from the craft, that will happen in around 60 seconds time from now. You then have the second stage, which separates from the capsule. It's then a 29-hour journey to the International Space Station. And what was so key about this launch window being on bang on midday Eastern time is that it was what we call an instantaneous window. It's the perfect moment to line you up with the right trajectory to get you to ISS.